At the Milky Way's core, Sagittarius A powers a hidden engine, a supermassive black hole of 4 million solar masses. For decades, astronomers assumed its feeding zone churned in pure chaos. Now, combined observations from Chandra, IXPE, and the Event Horizon Telescope reveal an intricate magnetic skeleton, vast filaments spiral inward, channeling hot gas along ordered field lines. Where disorder was predicted, a structured accretion disk funnels matter with unexpected precision. The monster does not blindly consume, it follows a magnetic architecture. Even knowing there is architecture, the true face of the beast stays hidden. Sagittarius A does not announce itself in flashes of visible light. It waits in darkness masked by its own feeding ground. This is a gravitational monster holding roughly 4 million times the mass of our Sun, all condensed into a space smaller than the orbit of Mercury. It sits at the core of the Milky Way, 26,000 light-years from Earth, buried deep within the galactic bulge. From our position on the outer spiral arm, the entire central region lies behind an impenetrable wall of dust. Thick veils of cold gas and microscopic grains, the very debris spiraling inward, block any chance of seeing the black hole with optical telescopes. Visible light simply cannot punch through those dense clouds. It is absorbed and scattered into random directions long before reaching any lens on Earth. For decades, the singularity remained little more than a theoretical ghost, its presence betrayed only by the violent dance of nearby stars. Those stars trace impossibly tight orbits around an invisible pivot, a point with no surface and no glow. To get even a glimpse of the structure around that edge, astronomers must tune into longer wavelengths. Radio waves glide through the dust with almost no interference. X-rays spike from ultra-hot plasma just outside the event horizon, a brief signal in the static. But resolving any detail at such a distance requires an instrument of planetary scale. The Event Horizon Telescope stitches together dishes across the globe, forming a virtual eye sharp enough to separate a black hole's shadow from its luminous ring. And what it finds emerging from the dark is not a blind, chaotic feast. It is a pattern, what may be a magnetic skeleton lurking beneath the shroud, hinting that the unseen monster follows rules we are only now beginning to decode. But to see it, we must first peer through the cosmic fog. The heart of our galaxy is a crowded, violent place. A dense thicket of interstellar dust and the blinding light of countless stars lies between us and Sagittarius A, roughly 26,000 light-years away. This shroud blocks almost all visible light, rendering the black hole itself invisible to our eyes. To pierce this veil, astronomers cannot use ordinary telescopes. They must turn to instruments that see the universe in different energies, specifically radio waves and X-rays. These can cut through the obscuring dust, revealing the high-energy processes at play. Yet even with this technology, Sagittarius A is a faint and elusive target. It is not a voracious, bright beacon like other supermassive black holes. It is a quiet monster, its faint whispers of activity easily lost in the galactic background noise. Isolating its signal from the stellar clutter is a monumental task, requiring not just one observatory, but a symphony of them working in concert across the electromagnetic spectrum. Now the symphony begins to play. 3 extraordinary instruments align their sights on the galactic core. NASA's Chandra X-ray Observatory, orbiting far above Earth's distorting atmosphere, brings the first voice. It peers directly into the superheated plasma swirling around Sagittarius A, detecting X-rays that escape from regions just a fraction of a light-year from the event horizon. The temperatures here exceed tens of millions of degrees, a realm invisible to ordinary telescopes. Chandra's decades of monitoring reveal a persistent, structured glow, not random flickers but a definable shape emerging from the noise. The second voice enters, the Imaging X-ray Polarimetry Explorer, or IXPE. This satellite does not just measure brightness, it reads the orientation of the X-ray light waves themselves. Polarization maps the direction and order of magnetic field lines, threading the accretion flow. When IXPE trains its eye on Sagittarius A, it uncovers a coherent magnetic skeleton, fields aligned in sweeping arcs that funnel hot gas inward. The data suggests a spiral geometry, a magnetic grand design where chaos was supposed to reign. Then the third voice joins, the Event Horizon Telescope, a planet-spanning network of radio dishes that achieves the highest angular resolution ever attained from Earth's surface. It captures the silhouette of the black hole's shadow, the base of this entire structure. By pinning the exact position of the event horizon, EHT anchors the X-ray features in space. The combined portrait shatters old models. There is no turbulent, haphazard infall here. Instead, the multi-wavelength image shows a spiraling, magnetically collimated funnel, detailed filaments stretching along magnetic threads, delivering matter with a quiet, disciplined rhythm straight into the void. But that now iconic ring of light, that shadow at the very precipice of the void, tells us only part of the story. It is a static portrait of the final moment, a cosmic shoreline. It reveals the event horizon's silhouette, but gives no hint of the vast, dynamic ocean feeding it. The EHT's singular snapshot is silent on the question of flow. It shows us the drain, but not the whirlpool. For decades, theorists have envisioned the final approach to a supermassive black hole as a zone of utter chaos, a place where gravity shreds matter into a turbulent hot soup that falls inward in a chaotic, violent rush. The Event Horizon Telescope image, while historic, could not confirm or deny this. It left the entire feeding mechanism, the how of the black hole's meal, shrouded in mystery. The image is a monumental achievement, but it is a frozen frame. To understand the movie, to see the current that carries matter toward that ultimate point of no return, astronomers needed to pull the camera back. They needed to combine that unprecedented detail with a much wider view, one that could trace the paths of hot gas and dust across light days of space. They needed to map the invisible forces guiding the fall. For over 2 decades, the Chandra X-ray Observatory has kept its watchful eye on the galactic center. Its data reveals a faint, persistent X-ray glow emanating from the region around Sagittarius A, the signature of gas superheated to millions of degrees. This isn't a uniform haze. Chandra has cataloged bright, unpredictable flares erupting from just outside the event horizon, sudden bursts of energy as material is violently stressed. But more telling is the steady, diffuse X-ray halo that surrounds the black hole itself. This is the hot gas reservoir, the fuel supply for the monster. The very presence of this structured glow, this halo, was the first major clue. It hinted that the chaos might have a pattern, that the swirling inferno of gas wasn't just a random tempest. Scientists could see the glow, but they couldn't yet trace its flow. They needed to understand the architecture of this hot atmosphere. The X-ray data showed the what, the searing hot material. The next step was to find the how, the precise, invisible pathways this doomed gas was following on its final journey. The halo was a signpost, pointing toward an order hidden within the storm. To read those pathways, astronomers turned to a new eye, IXPE, the Imaging X-ray Polarimetry Explorer. It does not just measure brightness. It traces the vibration direction of each X-ray photon arriving from the galactic center. Polarization is the key. When light scatters off hot electrons trapped in magnetic fields, it becomes polarized, its waves aligned in a specific orientation. By mapping that alignment across Sagittarius A's inner feeding zone, IXPE constructs a magnetic blueprint of the invisible. The result stuns researchers. Instead of a tangled magnetic mess, the X-rays show a coherent spiral. A substantial portion of the emission from the innermost region is polarized, with field lines sweeping in orderly arcs from a few hundred to a few thousand Schwarzschild radii. The vectors point along a grand, rotating funnel. Hot gas is not plunging randomly. It hugs these structured magnetic channels, spiraling inward at precisely measured angles, its final trajectory dictated from the very edge of the event horizon. This is the hidden framework that shapes the meal. Much of the stripped stellar debris and superheated plasma appears to be guided along these tracks. The chaos of the galactic nucleus now reveals an elegant, enforced choreography, a magnetic slingshot winding tighter as matter approaches the point of no return. The halo was indeed a signpost. It reveals a thread of an elaborate web feeding the monster in the dark, its appetite choreographed by invisible forces astronomers are only now beginning to see. To see the invisible threads, astronomers turn to eyes that perceive energy beyond human sight. The Chandra X-ray Observatory slices through the galactic haze, capturing high-energy radiation from gas heated to tens of millions of degrees as it spirals inward. But temperature alone cannot reveal the hidden architecture. This is where IXPE enters, measuring the polarization of X-rays cause the direction in which light waves vibrate. Polarized photons carry the imprint of magnetic fields, their alignment twisting in response to invisible force lines. And the Event Horizon Telescope provides the ultimate anchor, a silhouette of the event horizon itself, offering a frame within which to place the emerging picture. When these 3 datasets are layered, the chaos resolves into structure. Fingers of magnetized plasma, more than 150 light-years long, curl inward in a grand spiral. Hot gas does not tumble wildly. It follows organized magnetic field lines that funnel it toward the singularity like water racing down a whirlpool. Each magnetic filament anchors itself in a rotating disk, a vast accretion structure that maintains its coherence far closer to the black hole than turbulence models ever predicted. The polarized X-ray signatures spike exactly along these arcs, confirming that the magnetic field is not a passive bystander. It is the choreographer, threading the entire feeding zone and dictating the flow of matter on its final approach. Around Sagittarius A, the expected chaos is replaced by a magnetic skeleton, rigid and purposeful. The halo that first whispered of hidden order now sits as the glowing outer boundary of a systematic delivery system. The monster's feeding appears guided by magnetic fields, its appetite shaped by forces we are only now mapping. The glow approaching the black hole's edge should, by all known physics, dissolve into chaos. Where gravity sharpens to a tearing point and gas heats to over 10 million degrees Celsius, turbulence is supposed to dominate. Astronomers brace for a disorganized maelstrom, a zone where magnetic fields snap and reconnect in violent loops. That is not what the data reveal. Instead, combined X-ray polarimetry from NASA's IXPE satellite and detailed imaging from the Chandra Observatory expose something almost impossibly serene: a coherent spiral woven from highly ordered magnetic field lines. These fields do not tangle randomly. They align across a structure that funnels matter inward in a smooth, continuous flow. IXPE detects polarized X-rays emitted by electrons spiraling along these magnetic channels, revealing an orientation that holds steady from roughly 10 light-minutes away inward toward the event horizon. The pattern resembles the grooves of a vinyl record, guiding the superheated plasma step by step. Dust and gas, instead of plunging in sporadic bursts, are threaded along invisible rails that deliver fuel at a near constant rate. This order so close to the point of no return rewrites a central assumption about black hole feeding. The inner accretion zone was thought to be a messy boundary layer where magnetic friction creates erratic flares. Now it appears more like a calibrated engine component. The magnetic spiral exerts a quiet discipline, suppressing the turbulence that models predicted would wash out any structure. Sagittarius A does not roar. It breathes in an organized rhythm. That glowing outer boundary, the halo seen before, is merely the outermost signature of a delivery system whose true precision only now snaps into focus. The halo is not a static shell. It is the outermost curl of a far more deliberate architecture, a spiral that wraps around Sagittarius A in a tightening mathematical coil. Combined X-ray data from Chandra and polarized light measurements from IXPE strip away the blur and expose the true geometry. This is not a chaotic cloud of random infall. The material follows a coherent path, a continuous stream that loops inward along magnetic field lines, stretched into a grand helical funnel. Electrically charged gas and dust cannot cut straight across these magnetic rails. They are forced to slide along them, spiraling ever faster as they descend. Over millions of kilometers inward, the orbital velocity climbs steadily. Particles race at roughly 30% the speed of light by the time they enter the innermost coil. The friction of this structured traffic, gas shearing against itself in the spiral, converts gravitational energy into raw heat. Temperatures spike past 10 million degrees. The stream ignites an X-ray brilliance visible to Chandra as a persistent glowing track winding toward oblivion. What IXPE reveals is the alignment. The polarization angles of those X-rays trace the magnetic field lines in near perfect order, not the tangled mess theorists once assumed so close to the event horizon. The spiral is built like a spring, compressing matter into a narrow corridor. There is no random splashing, no sporadic gulps. It is a smooth, nearly rhythmic delivery, a steady conveyor belt that accelerates, heats, and finally feeds the shadow at the center. This deep spiral, hidden for decades behind dust and distance, now rewrites the basic picture of how a supermassive black hole sits and consumes. The breathing rhythm catches its truest form. What you once imagined as chaos, a violent free-for-all of gas and dust, turns out to be a profoundly ordered system. Polarization maps from IXPE expose a magnetic architecture that threads the entire spiral. Individual field lines, aligned like iron filings beneath a sheet of paper, stretch from the outer disk into the event horizon's very threshold. Matter does not hurtle in from random angles. It is caught, channeled, and governed. Old models depicted a turbulent feeding zone where clumps of gas would plunge sporadically, triggering unpredictable flares. This new view replaces that pandemonium with controlled descent. The hot plasma spirals along magnetic guide rails at roughly 2 million miles an hour, its path dictated by forces that bend but do not break. The magnetic field acts as both slingshot and brake, accelerating some material to generate the faint X-ray glow Chandra captures, yet imposing a deliberate pace on the overall inflow. This has direct consequences for the black hole's appetite. The feeding rate is not just a function of what drifts near. It is a carefully throttled process, tuned by field strength. Even the quiet epochs, when Sagittarius A dims to near invisibility, make fresh sense. A temporary magnetic logjam starves the core. When enough matter accumulates, the field reconnects, releasing a measured burst of radiation. A heartbeat of light 26,000 years from Earth. The breathing rhythm now has a mechanism, and it is entirely magnetic, but this magnetic pulse is not an isolated event. It is part of a much larger architecture. Extending from the event horizon, astronomers now see long, luminous filaments. These are organized magnetic field lines made visible, tracing a path from the chaotic inner spiral all the way out to connect with larger structures in the galactic center. They reveal a vast and hidden magnetic plumbing system. It is as if the black hole is not just a drain, but the central hub of an immense invisible network. These filaments are the conduits, the guiding rails along which material can flow over vast distances. This network shows that the influence of Sagittarius A's magnetic field is far more extensive than anyone predicted, reaching out to shape the environment light years away from the point of no return. The heartbeat is not just a local phenomenon, its pulse travels along these magnetic arteries, connecting the black hole's violent dinner table to the quiet outskirts of its domain. The order scientists have found is not confined to the accretion flow. It is written across the sky in lines of magnetic force, a blueprint for how a black hole interacts with its entire galaxy. The magnetic architecture mapped around Sagittarius A is not a fluke. It is a blueprint, precise, repeatable, and likely universal. If this ordered accretion structure exists in our own galactic core, astronomers now suspect it could govern feeding in many supermassive black holes across the cosmos. The Chandra and I XPE data do not just rewrite the story of one object, they rewrite the physics of black hole growth itself. For decades, simulations painted a picture of turbulent, chaotic inflows, hot gas crashing into the void from random directions. That chaos, scientists believed, limited how fast a black hole could consume matter. But the helical magnetic funnels delivering material into Sagittarius A reveal a far more efficient engine. Magnetized filaments lock inflowing plasma into streamlined lanes, drastically reducing turbulence and channeling gas directly toward the event horizon. This order turns a messy feeding zone into a high-speed conveyor belt. The implications stretch across cosmic time. If such magnetic scaffolding is standard equipment around growing supermassive black holes, it solves a persistent riddle: how some black holes gained billions of solar masses when the universe was less than a billion years old. Chaotic accretion cannot explain that rapid growth. Magnetic highways can. Many newly examined active galactic nuclei now become candidates for this hidden order, their X-ray polarization waiting to expose similar inner spirals. The blueprint drawn by Sagittarius A forces a fundamental shift. Black hole feeding is not a random scramble, but a structured, magnetized flow. That quiet heartbeat, first detected pulsing along the filaments, now echoes far beyond our galaxy, a signal that the same invisible arteries may be threading the dark hearts of distant quasars, driving the growth of the mightiest engines in the universe. That pulse is not a faint echo. It is a metronome. The Chandra X-ray Observatory and the Event Horizon Telescope have now correlated these rhythmic flickers with hot spots embedded within the newly mapped spiral accretion flow. At roughly 30 million kilometers from the event horizon, hot spots of plasma orbit every 70 minutes or so. As each knot scrapes against the helical magnetic field lines, it releases a precisely timed X-ray flare. This is Sagittarius A's heartbeat, a signature not of chaos, but of a tightly wound magnetic clockwork. But clocks can break. Right now, the organized field channel's just a trickle of gas inward. A single disruption, a passing giant molecular cloud, a star cluster nudging the accretion disk, could inject a sudden deluge of material. If the magnetic structure frays, the orderly funnel collapses into a chaotic torrent. In mere decades, a black hole that has been mostly dormant for millions of years could reignite into a blaze thousands of times brighter. The filaments we see now are a fragile architecture. Their persistence has lulled the galactic center into an unusually quiet state, allowing life to evolve in the galactic suburbs without sterilizing radiation storms. This magnetic blueprint does more than explain the flickers. It exposes the trigger mechanism. The supermassive heart of the Milky Way is not dead. It is sleeping in a cradle of unseen magnetic coils, its faint rhythm a warning. When that field ruptures, the silent center will roar awake, and the heartbeat will quicken into a scream that rewrites our galaxy's history. The magnetic map is now clear. Using polarized X-ray light from NASA's IXPE telescope, astronomers trace more than a dozen enormous filaments spiraling inward around Sagittarius A. Each filament stretches roughly 10 to 15 light-years, following a helical pattern that feeds hot gas directly toward the event horizon along organized magnetic field lines. Chandra X-ray data confirms these strands are not random turbulence. They form a coherent spinning accretion structure, a magnetic funnel built like a corkscrew. This level of order changes the fundamental picture of how a black hole eats. Matter does not plunge in from all directions in a chaotic freefall. Instead, the magnetic field acts as a guiding scaffold, channeling plasma into a narrow, steady flow. The Event Horizon Telescope's images of the glowing ring now match precise polarization signatures from this structured inflow. What we once called a messy feeding zone now appears closer to a regulated cosmic engine, one that has likely been shaping the galactic center for millions of years. Yet humility remains. We are peering across 26,000 light-years through a thick veil of dust and scattered starlight. The resolution is at the absolute limit. The magnetic field geometry is inferred, not fully seen. We cannot predict when the field might twist, snap, or release the enormous outbursts that shape galaxy evolution. The engine's blueprint is only partially read. But the outline is undeniable. A sleeping giant cradled in a cathedral of ordered magnetism, its whisper already echoing in the X-ray light. And now we know how to listen.